far. Monday, Tuesday, and Thursday. So today's new lesson, I'm calling it Translations of Parabolas Quadratics. Translations. What that means is moving the graph around. We'll look at that later. Morning, Leja. Thanks for joining.
Good morning, Josiah. How are you this morning?
Oh, pretty good. Thanks for asking.
Of course.
So just to give you a heads up, actually, I'll just say this for everyone here. Let's see. So today, my plan was to review homework graphs from Tuesday, the 3 graphs I gave you all for your homework problems. Review vertex form of a quadratic. Remember quadratic, parabola, same thing. So vertex form. I wanted to quickly review zeros and x-intercepts. So I'll review first, and then if we are able to get to it today, I want to start some new stuff, defining the parent graph using the parent graph and vertex form. This is, I should have maybe just called this translations. Translations. Define how the number A, is used in graphing. So it's kind of a maybe overly ambitious lesson for today. We'll see if we get to this. I want to do my best to get to this, but I want to review with you all and make sure everyone's feeling better after reviewing than you do right now about what we've just started so far. So graphing and the vertex form that we did look at and finding zeros. Also, there was the axis of symmetry formula that we should review that as well. And then if we are able to, I want to try to get to these new items below here, new stuff. Any questions or concerns right now, please?
When will we be done with this unit?
I think still next week. We can probably be testing on it on Wednesday and count it for the month. For
Okay.
what are we in? Month 4? Yeah.
Yeah.
There's really not too much new stuff to go, but I want to make sure everyone's ready and good to go on what we've done so far, and then these new items that we haven't done yet that I wanted to start today. So that's the plan, is next week, Wednesday. Anything else? Any other questions? All right. Well, those of you who already did or attempted the homework from Tuesday, any questions on those 3 graphs? Here's the equations, the functions that I gave you on Tuesday to graph. And I didn't get the homework from everybody yet, but a lot of you did do the graphs and send them to me. I send a picture. So thank you for doing that. Any questions? Did you want to ask about any, or any trouble when you were doing it?
Yeah, I didn't understand how to graph it.
Yeah, I had trouble on it too. It was really hard.
Yeah, I was struggling.
Let's look at them now. So before we do one of them, the basic steps is we need to find the vertex, or we need to find where the axis of symmetry is. So I don't want to overcomplicate like how to do this. So I know I might, right? I might make it more confusing than I need to. So the basic first step when we're graphing these guys, these parabolas, first steps is find the vertex. And if it's in standard form, like number 3 is at the bottom, we can't know the vertex just by looking at that, but we can find the axis of symmetry. So, or find the axis or the line of symmetry, axis of symmetry. This we did on Tuesday, the axis of symmetry. The formula is x equals negative b over 2a. And a, b, and c, the a and b, those are just the numbers, the coefficients in your standard form parabola. So we only worry about axis of symmetry if it's in standard form. If it's in the first two forms, remember number 1 and number 2, those are in vertex form. So it's basically telling us the vertex right away. So those are our first steps, is find the vertex or find the axis of symmetry. After that, down below, my next step would be we need to plug in some x values. In the neighborhood of our vertex, meaning the two numbers like higher than our x in the vertex or the two numbers lower than x in the vertex. That's what I mean by the neighborhood, two that are around it. So plug in some x values in the neighborhood of the vertex. When we plug in our x values, we're not just plugging them in and walking away, right? We're plugging in a couple x values, solving it for y. So that's what I mean when I say plug in some x values. So we're going to plug in a few numbers for x and then solve it for y, and we're getting a few points. So let's look at number 1. These are our basic steps, okay? We need to find the vertex. If we can't do that, then we're going to find the axis of symmetry using this formula. X is equal to negative b over 2a. After we do those first two steps, either or, then we do the plugging in x values. Any questions or comments before we try number 1, number 2? Okay. All right, let's try a couple of these together. Number 1. Now, this is in vertex form. We have x plus 2 squared minus 1. Can anyone tell me what they think the vertex might be based on what we're seeing in this equation? Any ideas? What's the vertex? Does anyone remember or have a thought about how we can find it?
I think I got it.
Go for it, Leisure.
The vertex would be -2 and -1.
Wonderful. Thank you. Yes. -2, -1. The number in with the x, that's h. And it's actually the opposite sign of whatever it looks like. So this is plus 2, right? In with the x. So opposite sign would be -2. Then k is the other number on the outside, and that's at face value. So it's already -1, so we take it at face value, it's -1. So our vertex for this problem is -2, -1. That's our first step. That's a lot of good information. Now we know where to kind of start this thing. So to graph it, I'm going to make a generic graph. Start with your x line and then your y line. I know where kind of the focus is going to be. The middle of my picture needs to be around -2, -1. That's why we want to find that first. So I'm going to make sure to start by graphing that. So here's my -2 on x, and then my y needs to go down to -1. And I'm going to just put a few more spaces or units in there, right? So just keep going a little bit. It doesn't have to go on forever. -1, -2, -3, -4. Back here, let's do a few more as well. Some. And I'll do some of the positive ones too, so we can see what's going on there. Remember, it doesn't have to be perfect, but I just want to see you trying. Mine's not perfect either. Okay, so there's my blank graph. Now let's put the vertex in there. So -2, we always start, just as a reminder, the first numbers are x number, left, right. The second one is our y, up, down. So I'm going -2 on the x ruler and then -1 from there. So right here. And you know what? I'm going to change my color so it'll pop a little more. Hang on. All right, so I'm going to do it in purple here. So -2, -1 for my vertex. Now, just a reminder, the vertex, look at the left side of my screen with me. For any of these parabolas, the vertex is the point where it's like the bottom of the bowl, or maybe if it's upside down, it's the top. And it's the point where it changes direction. So kind of turns and goes back the way it came. So that's what's happening at -2, -1. But I still don't know exactly where the x-intercepts are, where the y-intercept is. Like, where does the rest of this parabola land? All we know so far is the vertex. So, what was our other step after we find the vertex or the line of symmetry? It's to plug in some numbers for x that are in the neighborhood of the vertex. Good morning, Bailey. We're just going over the homework that I gave you all on Tuesday.
Okay.
Kind of a review of how to graph these parabolas. Okay, so we've got our vertex. The number we're interested in is -2. That's the x value of our parabola, of our vertex, I should say. Sorry, the x value of the vertex. And it's on that line. That's the axis of symmetry, or the line of symmetry. So what are some numbers in the neighborhood? We could choose -1 and 0. Or if you felt like it, we could do the two numbers on the other side. We could do -3 and -4. But either way, I want to pick two of those numbers, and we're going to plug them in for x in our formula that's above that we started with. Remember the formula, the equation, this is the function. This is the parabola. It's like the map that tells you all the different points on that function. So here we go. Let's do a couple points in the neighborhood. X plus 2 squared minus 1. There's the formula. I'm going to plug in the, I'm going to choose to do the -1 and the 0. They just seem a little simpler than -3 and -4 to me. So I'm going to do those ones. So let's plug in x is equal to -1. So here we go. Y is equal to -1 plus 2. So just notice that all we're doing is switching out the number -1 for x. Why are we choosing -1 again? Because it's near our line of symmetry. It's near the vertex. Now let's just simplify using PEMDAS and order of operations. So we want to clean up inside the parentheses and then square it and then do -1 for that outside -1. So this becomes -1 plus 2. Well, that's +1. 1 squared is just 1. 1 minus 1 is 0. So we plugged in, and you know what? To keep track of my work, you should do this too. On the top right of my screen, I'm going to make a table with x's and y's so we can keep track of what's going on here. So let's back up a second. I'll put my vertex in the table. I'll put that right here. -2, -1. That's our vertex. And now for the point we just did -1 for x, and we got out a 0 for y. -1, comma 0. So let's put that point on our picture now. -1 on x and 0 up or down, so that's right on the line, right here. I'm going to stop there for a second. Any questions or concerns about what I just did, finding that second point? Please. Do we all feel comfortable with so far? Okay, so let's talk about the symmetry real quick. Remember that these parabolas we're graphing are symmetrical, meaning like the left side of it is matching the right side of it, like mirrored across the line of symmetry. So that means right across the way from the point we just made. See how this point -1, 0? It's one space, one unit away from the line of symmetry. So that means on the other side of the line of symmetry, there's another point just like it right here. I'm gonna keep that one like not filled in. We didn't solve for that one, but that is another point on our parabola, and we know it just because the parabola has symmetry. So if you find some of the points on one side of the parabola, I want you to save time. Instead of plugging in the other side as well, we're just going to mark them using symmetry, like I did for this one, -3, 0. I'm going to put that in my table, -3, 0. So, I mean, technically we could probably be done now, but I'm going to do one more point in the neighborhood of -2. So just like we plugged in -1 a moment ago, let's plug in the next number on the right side of my parabola, which would be right here. X is 0. So starting from the beginning, I go back to my equation, and I'm going to plug in 0 this time. So x is 0, and let's see what we get for y. And now we're just doing some algebra, just cleaning up, just arithmetic. 0 plus 2 is 2. 2 squared is 4. 4 minus 1 is 3. So y is equal to 3. When x is 0, y is 3. When x is 0, y is 3. I'm adding it to my table. And now I'm going to graph it. So 0 left to right. So that's right in the middle. But then up 3 right here. So there's our next point that we found. Now that I've got the vertex and 2 points on the right side, I'm going to connect those dots basically, make it a nice curve like this. And then after that, let's just estimate what it looks like. I'm just going to kind of keep it going upwards like this. And now I want to finish the other side of our graph. So let's do symmetry to find the point across from that 0, 3 point. So that's one space away, one space away. So that's a total of 2 spaces away. So then 2 spaces away on the other side will give us the next point. So 1, 2, right here. So let's connect those dots. We want to start by just finding the vertex. Without that, it's impossible to know like where we should be graphing this thing. If we didn't know the vertex and we just started randomly plugging in numbers for x, that would be better than nothing. But what if I chose to plug in, let me change my color really quick. What if I chose to plug in numbers that were like not around the neighborhood of the vertex, and I just kind of picked, oh, x is 1, and that would be this spot right here. And then x is 2, and that's like even higher. X is, my point is, what if I just pick these spots, and all we have is this like kind of straight looking line? That doesn't really give me a good idea of where the whole parabola lives, right? That's just like, um, it almost looks like a straight line at that point. We don't get any of the curve there. So that's why we want to find the vertex and then just go right around it on the left and on the right. 2 points on the right or 2 points on the left. Use symmetry to find the spaces or to find the points that are across from those, like we did in this problem. And then we're done. So that, I think that makes it easiest if we know where the vertex is and then plug in some values for x that are near in the neighborhood of h, of the x part of the vertex. In green here, this is why we don't want to just randomly pick x values, because who knows where they are, right? Who knows if they're near the vertex at all? They might not be. Most of the problems I've been giving you are parabolas are pretty close to like the middle of the graph, right? 0, 0. But what if this graph was like way over at like 100? What if it was something like this? Sorry. Okay, so what if our graph, what if our parabola was something like this? And this vertex was at like 500, comma, negative 100. Something crazy and ridiculous. So that's possible, right? And if I didn't know that ahead of time and I just had the formula and I was trying to find some points and I plugged in like x is 1 and x is 2 and x is 3, well, those are so high up on this graph, like so high up, who even knows how high that is? It's probably in the millions or something. So that's why it's important to start with finding the vertex, because that tells you, okay, this tells me where the curve is, where it's nice and curvy and close to like the beginning of this graph. It's a good place to focus on. That's why we want to start by finding the vertex or the line of symmetry. Here's that problem number 1 again. All right. A lot of people are saying that they weren't feeling terrific about this and had questions and were iffy, but no one's asking questions. Let me just switch over and look at your guys' screens quick. Let's see thumbs. How are we feeling right now in this moment about graphing in vertex form like we did on number 1?
I only had a problem with number 2.
Number 2? Okay, thanks, Manaya.
I only had I only got confused on the third problem, Josiah.
The third one. Okay.
I mean,
So you
yeah.
two seem like you were comfortable with number 1.
Yeah.
Okay.
For me, it was the steps to how to solve it, but I wrote them down, so now I kind of get it a little more.
Okay, that's good to hear. A little better. Well, someone mentioned number 2 and number 3, so let's look at number 2. So number 2 is also in vertex form. So frankly, the numbers are different, right? But number 2 is basically the same type of problem as number 1. Let's look at this. Step 1 is find the vertex. And this is in vertex form, so this should be fairly fast. Remember, the formula is x minus h. So whatever we see in there, in this case, it's negative 3, right? I'm going to change that sign, and that's my actual h. So h in this problem is positive 3. take k at face value. So that's going to be -4. K is -4. So together, that's my vertex, HK, 3, -4. And that's where we want to anchor our picture, our graph, at 3, -4. That's why we want to find that first. This time, let's see, x is positive, or I guess it's h, right? The h number is positive. So I'm going to move to the rightwards of my graph instead of the left like last time. So 1, 2, 3. And then try to make your units the same. Remember, don't be hard on yourself if it's not perfect. I know the desire to make it perfect is, you probably have that. I do too. But we can't always be perfect. So just do your best to make it well, and then in time it'll get better and better and better. 1, 2, 3, 4. Okay, so there's my -4. Okay, so those are the ones we actually need. I'm going to throw in a few more on the other side so we get some context. Okay, so 3, -4. Let me change my color here. So 3 to the right, and then down 4. Here we go. There's our vertex. Now, I'm going to throw in the line of symmetry just for fun. It's basically a vertical line cutting through that vertex we just made. This helps me see where my parabola is going to be split down the middle. So going straight up and down through that vertex, you can imagine a dashed line that's cutting our parabola in half. So hopefully your mind's already imprinting where this thing is going to be. We know, I'm going to just draw it real quick and then I'm going to delete it. It's basically going to look like this. Right? We know it's going to be that shape, and we know the vertex is where it's changing direction. So it's going to look like this. I want to find those exact points though, just to be safe. So I'm going to erase that quick and find those legitimate points. Okay. All right. So let me ask you, what would be 2 points in the neighborhood, quote unquote, of 3? What should our x values be that we're going to plug in? Any ideas?
Two.
Totally. 2 is right next to that. So I'm going to I'll just make a star by that. We're not graphing it at 2. We're just making a little note. How about another one? If we do 2, what should we? Yes. If we do 2, let's do the next one going over. Perfect. So we're going to do x is 2 and x is 1 into the formula from the beginning. So y equals x minus 2. And I'll make a note of that. We're doing x equals 2 here. There we go. Oh, wait a minute. No, I'm totally tripping. Let me start over. That's a disaster. Okay. Okay, double check that you didn't copy down some wrong information. Okay, it's x minus 3 squared, right? So we're replacing 2 for x. So 2 minus 3. 2 minus 3 in our parentheses. All right, now go to town. 2 minus 3 is -1. -1 squared is +1. Remember, negative times a negative is positive. 1 times 1 is 1. 1 minus 4 is -3. So we plugged in +2 and got out -3. I'm going to make a table to keep track of my work right here. We plugged in a +2 and got out -3. Vertex was 3, -4. So let's put that in the table. And let's also graph the new point, 2, -3. So over 2, down 3 right here. There's our new point. And now someone said we'll plug in 1, so let's do that. Starting over. Y is equal to x minus 3 squared minus 4. Let's plug in our 1. 1 minus 3 is negative 2. Okay, negative 2 squared. Well, 2 times 2 is 4. Negative times a negative is positive. So that's going to become positive 4. 4 minus 4 is 0. So y is equal to 0. Plugged in a 1, got out a 0. So 1 comma 0 right here on the line. Okay, we can connect those dots. Don't make them straight, make it a little curvy like that. That's good. And now let's use our symmetry to make the points on the other side. So, you know what? I'll do this in red to kind of contrast with what we've got going on. So our first point we found was 2, negative 3. So that's 1 unit away from the line of symmetry. So 1 unit on the other side, right here, that's 4, negative 3. I found that using symmetry on the picture, not even doing any math. Now we'll do the same thing for the other line, or the other point. This is 2 units away. So 2 units away here, 1, 2, 5, 0. 5, 0. So those are legitimate points on our parabola, and we didn't have to use any math. We just used the picture and the symmetry, the mirror image. Connect those guys, and we're done. I'm only using different colors to show that we use the math to find the black points. I used symmetry to find the red points. Left, we actually solved for those, right? On the right side, though, we kind of cheated. We just kind of used the symmetry. It's not actually bad. It's the only type of good cheating I can think of. We used our symmetry, so we used it for positive. Now, if you wanted to be double sure, you could plug in those x values. If you plugged in x is 4 into the equation, you're going to solve through and get negative 3. I'm adding that to my table. And if you plugged in a 5, x is 5, you will get 0. And check out the table with me real quick. You should see symmetry in the table. The vertex, I'm going to kind of circle that in my table. And then check out the y values around it. Negative 3, 0, 0. And if you did more, like 6 and 0 for x again, then it's going to have more symmetry on the table. So that's kind of a useful tool if you need it. There's symmetry in the table as well. Any questions on number 2? Concerns, please. Okay, well, do we need more time on number 2 before I look at 3?
I don't think so.
Okay, thanks, Leja. Just double checking. I'm sure not everyone's like ready to talk. Okay, number 3. So number 3 is the only one I gave you that's in standard form. So this one's a little extra work. We've got to figure out, well, where do we start this thing? A is 1, B is 2, and then C is negative 8. Now, if it's in this form, we don't know the vertex, right? So we're going to use that special little formula, the line of symmetry or axis of symmetry. X equals negative B over 2 times A. This tells us where to start. It's not giving us like the whole vertex, but it is telling us the X part of the vertex. I guess technically it's H. This is telling us what H is. H is equal to this. So let's plug in our stuff and see what we got. So -2, because b is 2. 2 times a is 1. So we've got -2 over 2 times 1. -2 divided by 2, -1. So my line of symmetry is x equals -1. And technically, this is also the h number. So that's useful. All right, so I know that we're going to be over on the left side of our graph, not the right side. So here's -1. Let's throw in -2 and -3. So we know that the vertex is somewhere on this line. Here's my line of symmetry. To find k, to find how high or low the vertex actually lives on that line, we have to plug in -1 to the formula. So let's do that. So now I'll put this at I'll label what I'm doing here. So we are plugging in x is -1 to find the height of the vertex. So same formula, right? The formula, the equation, it is the function, it is the parabola. So always go back to the beginning of that when you're looking for new points. Y is equal to x squared plus 2x minus 8. I'm plugging in -1 here. Whenever you're plugging in a negative number to some equation, I always would put parentheses with that negative number, just in case. If it's positive, it doesn't really matter. But if it's negative, use your parentheses. -1 squared should give us +1. 2 times -1 is -2. Bring down that -8. Okay, 1 minus 2. So just those two. I do them in like one step at a time. 1 minus 2 is -1 or -1, right? Bring down the -8. -1 minus 8, that's -9. Yikes. Y is equal to -9. So now we know the vertex. Let's put this in the bottom. The vertex is -1 comma -9. All right. I didn't realize I gave you one with -9 in it. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So there's my -9. Yikes. All right, so now at this point we know the vertex, and let's graph it. I'll make it nice and big so you can see it, hopefully. All right, now we just do the neighborhood. We're going to plug in numbers in the neighborhood. So let's do, it doesn't really matter. I'm going to go with the positives, okay? I'm going to plug in x is 0 and x is 1. Those are the next two numbers closest to our line of symmetry. And I like positives whenever I can get them. So I'm going to do x is 0. Starting from the beginning, I plug in as 0. 0 squared plus 2 times 0 minus 8. 0 plus 0 minus 8 minus 8. So that is 0 to the left, right, and then 8 down right here. Nice and big. All right, now we're going to plug in x is 1. 1 squared plus 2 times 1 minus 8. 1 plus 2 minus 8. 1 plus 2 is 3. 3 minus 8 is negative 5. So we plugged in a 1, so that's over 1 and then down 5 right here. Good. And now we can connect those. There's our picture. And then let's use symmetry to do the other side. So one across here. I'll make these ones hollow. And then 2 across here. 1, 2. And I'll connect those. I'm just keeping them hollow to kind of show the difference there. We just found those with symmetry. So if it's in standard form, we have an extra step to take. We've got to start by using our line of symmetry formula, and then we plug in that number. We plugged in -1 for x to find where the vertex actually is. And then we can do the rest just like the other problems, doing the neighborhood x's. All right, let's see. Let's do a little more review of some other topics that are related to this. I wanted to talk about, well, we've talked about this a lot today. The vertex form of a parabola. H and K are the vertex. And notice in the formula, it's x minus h. So it's not x plus h, right? It's x minus. So because that's built into the formula, that's why we're always changing the sign. So if, quick example, y equals x plus 10 squared plus 50. Vertex here, well, what's the number in there with x? It's positive 10, right? Flip the sign, change the sign. It's going to be negative 10 for h, and then k is taken at face value, so it's positive 50. So the vertex here, negative 10, 50. Just an example. Let's talk about the zeros real quick. We did these in two different forms. So if you have a graph given to you, let's say we had this graph here, and we had our parabola crossing through at 1 and 5. The zeros here are x is 1 and x is 5. It's wherever the parabola is cutting across the x-axis. It's not the vertex, right? That's different. But we do know that the zeros are x is 1 and x is 5. And how does that correlate to the equation? Well, that means that if we were to factor the equation, we know that the factors, that's the two parentheses, the factors. Remember how we factor polynomials in Unit 2? Well, we go through that process and we get those two parentheses multiplied together. Because they're multiplied, they're called factors. Those two factors are going to be the opposite looking of whatever our zeros are in the picture. The whole point is the factor is turned into a zero itself. So to make x minus 1 into 0, well, that means x has to be 1. And to make x minus 5 into a 0, then that means x is 5, positive 5. And that correlates to the actual graph. That's at those numbers, positive 1 and positive 5 is when our picture is crossing through the x-axis. This can be kind of tricky. It's easy to forget that it's the opposite signs here. So the zeros will be positive, but then in the factors, they look negative, and vice versa. Okay. We've only got 15 minutes, a little less than 15 minutes. So let's look at a few new items, and then we'll stop for today there. All right, so here's some new stuff. Parent graph of a parabola. Parent graph. You might have heard this term before, and you might not have. The parent graph for any different function is always the simplest version, okay? That's what we mean in math when we say the parent graph. It's the simplest version of that type of function. And always, 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 the parent graphs are kind of anchored around the origin of the XY chart. So 0, 0, right in the middle. And notice that for my parent graph of a parabola, the vertex is right at the middle, 0, 0. So the equation for the parent graph of a parabola is this: y is equal to x squared. Doesn't even look like a parabola, or it doesn't look like a polynomial because there's no x number and there's no constant number. So there's no b and c. I mean, I guess b and c would be 0 is what's happening here. So there's the equation. It's just y equals x squared. This is the simplest version of a parabola, of a quadratic. So in vertex form, you could say it looks like this. The vertex form of the parent graph would be y equals 1 is a, h is 0, and k is 0. So technically speaking, this is the parent graph in vertex form. But what happens if you simplified this? Well, x minus 0 is just x. We don't have to show plus 0 or minus 0, right? Because it's not changing it. So we can cross that plus 0 out. And 1 times x squared, that's just x squared. So if you write this out in vertex form, it's a little redundant. Like we don't need to show that 0 is the h and 0 is the k. It's implied because there's nothing in the parentheses with x, right? There's no other number there. So it must be plus 0. I just mentioned this. A is 1 for the parent graph, and hk is 0, 0. Now, this is going to be useful to us because, and I can only imagine what people are going to think when we start graphing in a slightly easier way. If we can start using the parent graph, this image I'm showing you now, and then the idea of translations, this is going to make our graphing of parabolas and quadratics much easier, much faster than those 3 examples we just did. I think it's important to be able to do it the full way, okay? So I do want everyone to be able to graph a parabola like those 3 homework problems, like I taught you on Tuesday. However, this new way is easier, but I think it's only easier if you understand, have a better understanding at least of the first way. So, like if I taught you this first, it might not have helped. So I think this will be better. Here we go. Okay, let me go back one second. So the parent graph. So since we know that the most simplest basic version of a parabola, it starts at the origin 0, 0. And then notice the first time, if we just kind of follow up on the right side, starting from 0, 0, moving up the right side, moving up, moving up, moving up, right, this way. Look and see where it's crossing over the whole numbers. It crosses over right here. And then it does it again later at 2, 4. The next one would be 3, 8, but 8 is too high on my picture. I got that cut off. It would be up here somewhere, right about here. Over 3, up 8. And this is what I want you to look for in your graphs is vertex starts in the middle, and then it's up 1 over 1 for that first like whole number connection. And to the next whole number connection, the 2, 4 spot in the parent graph, that's up 4 units total over 2, up 4 squares or up 4 units over 2 to get to that other location, right? And then you could use symmetry on the other side, here and here. So here's our approach to translate or move the parent graph for other parabolas. Here's another parabola in vertex form. Graph the function. So if we weren't using translations and we weren't using the parent graph idea, to graph this, we'd have to go through all the steps we were doing for our review and on Tuesday. But we know that the parent graph looks like this. Oops, I made a mistake. Hang on. We know that the parent graph looks like this below. So if we kind of start with that, parent graph starts at the vertex or the origin, goes to this spot, 1, 1, and then it goes to 2, 4. So I'm graphing the parent graph here. 1, 2, here we go. So here's the parent graph. But our actual problem above, it has an h of -5 and a k, let's write that down. It's -5, 2. So what I want you to imagine doing is starting with the parent graph and then just dragging it over up and to the left, depending on whatever the h and k are. So here's the parent. I did the other side with symmetry. And this says my h is -5. So that's kind of like, let me change my color here. Change it to red. So I'm going to take my original vertex and move it over 5 to the left. H is -5, right? So I'm going to drag my vertex over 5 units to the left. 1, 2, 3, 4, 5. And then 2 units up. 1, 2. -5, 2. So this is the actual vertex for our problem, right? But I'm using the parent graph to kind of grab it and drag it across the screen, so to speak. So my old vertex was here at 0, 0, but for our problem, it's at negative 5, 2. So all the points on the parent graph are moving with it. So that means that this spot that was 1, 1 right here, originally on the parent graph, well, that's going to be up 1 square over 1 square like this right here. And that third point, which was at 2, 4 originally on the parent graph, well, that's up, it's over 2 and up 4 from whatever the new vertex is. So up 4. So let's see, 1, 2, 3, 4. So it's going to be this high. And it's going to be 2 spaces away from the vertex. 1, 2. So right here. And then I'm just going to throw the other side in symmetry like that. So here's the actual function for this problem. Y is equal to x plus 5 plus 2 in red. And we can use the parent graph as like a model or a guide. They're all going to be that same shape. They're all going to be that same shape. And we just need to know, okay, it's always going to be up 1 over 1 for that first point, and then up 4 over 2 from the vertex for the next point. And it's just a matter of where's the vertex, where do we start this thing, and then we can do the rest really fast. Let's try another one. Here's example 2. H this time is a positive 6. K is a negative 5. So I'm going to do it this time without even putting the parent graph on there. We know vertex is at 6, negative 5, like this. 1, 2, 3, 4, 5, 6. Down 5. So here's my vertex. And then up and to the left, one square up, 1 square to the left. That's our next one. Up 1 over 1. And then up 4 over 2, or over 2 up 4 from the vertex. So that's like, in my mind's eye, I'm kind of tracking it out. I'm counting up. 1, 2, 3, 4. So at this point here, at negative 1, and then it's over 2 squares. So it's not at 6, it's going to be at 4. So at 4, negative 1, here's the next spot. There's my parabola. And then you can use symmetry on the other side like we have been doing. So if we can, I guess I am basically asking you to memorize the parent graph. The parent graph is the most basic, and it always has that same shape. And then if we know the parent graph, and if we feel comfortable with that one, I'm going to go back to that real quick right here. Here's the parent graph. Then we can just imagine dragging that across the screen to wherever our new vertex is. And if our problem's in vertex form, then it's just a matter of dragging our parent graph from the starting location in the middle up and over or down and over for our new graphs. I guess it's time to go. My clock's back. So we didn't get to everything today. I'm going to just give you one homework question. We've already got the other graphs to make, and I don't think everyone finished all those. So today's homework for this weekend. Y is equal to x minus 7 squared plus 5. try graphing this using vertex form, translating it instead of doing all the different calculations. But if you can't do it based on this very short lesson we had today, that's okay. Don't feel bad, but just give it a shot and just add this one homework problem on to the other 3 from Tuesday.
Have a good day.
Okay,
Josiah.
you too. Thanks, everybody. Have a good day.
Thank you, Josiah. Have a wonderful day.
Thanks, Leja. You too. Bye, Keegan.